Lesson 2, square roots and cube roots. In lesson 1, you learned the properties of integer exponents. Now take a look at this problem. The length of each side of a square measures s inches long. The area of the square is 49 inches squared. What is the length of one side of the square? Notice that all four sides are marked with an S. Now, all four sides are equal because this is a square. Okay, that's what makes a square special. A says, describe in words how to find the area of a square given that each side is S inches long. If you are trying to find area, typically you would say length times width. So, length times width. And in this one, both of those are S. So, side times side. Okay? It's a square. Squares are special. All four sides are equal. You would find the area by multiplying two of the sides together. So side times side, and that's just representing the length and the width. B says write a multiplication expression using the variable s to represent the area. Well, if it's side times side, it would be s times s. Write an expression using the variable s and an exponent to represent the area of the square. Well, s times s with an exponent would be s squared. Write an equation. Okay, these were expressions. Expressions are half of an equation. Write an equation setting your expression equal to the area of the square given in the problem. Now, area equals side squared. That's your equation. But they did tell us that the area is 49. So we're going to pull the A out. We're going to put the 49 in. So 49 is equal to side squared. Consider the factors of 49. Explain what the two sides of the equation have in common when you write each as the product of two factors. Think about 49. What two identical factors could we multiply together to get 49? If you remember your perfect squares, 7 times 7 makes 49. If you was comparing the formula side times side and the factors of 49, 7 times 7, that's going to tell you that the side length, one side, would be S. S equals 7. The number 49 is one of a set of numbers called perfect squares. A perfect square is a number that results from multiplying an integer by itself. The first 15 squares are shown. All of these should be on your graphic organizer because they was in that last video. Look at the equation you wrote on the previous page, s squared equals 49. How do you solve an equation where a variable squared is equal to a perfect square? You have solved equations before by using inverse operations. This was also in your video. You solved addition equations by subtracting. You solved division equations by multiplying. What is the inverse operation of squaring a number? This was also in the video. The opposite of squaring a number is the square root. The inverse operation of squaring is finding the square root. A square root is any number that you can multiply by itself to get the original number. So there's you some notes for square root. For example, 3 is a square root because of square root of 9 because 3 times 3 equals 9. Another square root of 9 is negative 3 because negative 3 times negative 3 is positive 9. Now, the radical symbol means positive square root. So the square root of 9 equals 3. They're telling you that you could have a positive square root. You could also have the negative square root. typically you are just using the positive. So when you just see the radical symbol without this plus or minus, they only want the positive one. S squared equals 49. The inverse of squaring is to find the square root. So to find S, you're going to take the square root of S squared, which will cancel out the square, which is what they've done here. So S is equal to positive and negative square root of 49. That's finding the square root of both sides. And then S is equal to positive and negative 7. 49 is a perfect square, and that square would be positive 7. Now, we throw out the negative for a reason. If you measure a square, you cannot measure a negative 7 inches. Okay, it would have to be positive. Positive is the only solution that makes sense. That's why they throw the other one out. What is the difference between dividing 16 by 2 and finding the square root of 16? When you divide by 2, okay, dividing by 2 cuts the number in half. Okay, it gives you half the value. A square root, bless you. A square root gives you the two identical factors that equal the number. Let me change that. Factors whose product equals that original number. Okay, I know that's a lot. Take a minute and copy it down. Roots. Read the problem below, then explore how to solve equations with cubes and cube roots. Each edge of a cube measures a feet long. The volume of the cube is 125 feet cubed. What is the measure of each edge of the cube? Now remember, when we were talking about area, it was two-dimensional. We had a length, we had a width. When you're talking about volume, you've got that third dimension. It's a three-dimensional figure. You have a length, you have a width, and you have a height. That's where the third dimension comes from. Also, when they're talking about volume, notice that they're cubing your units, that feet cubed, and then in the last one it was squared. Okay, area is squared, volume is cubed. Looking at the diagram, it says draw and label the cube. We've got this three-dimensional cube. Remember that a cube is like a square. All of the sides are the same except it's three-dimensional. The length, the width, and the height of the cube each measure a feet, so all three dimensions are the same, and the volume is 125 feet cubed. That means you could fit 125 one-unit blocks inside of that cube. You can apply the formula for the volume of a cube. The volume of the cube is the product of its length, its width, and its height. The length was A, the width was A, the height was A, and that was equal to the volume. Now, take your multiplication expression and change it to an exponential one, and you end up with the base, A, with an exponent of 3 representing the 3 times they multiplied it. So A cubed is equal to the volume. Now they told us the volume up here. So you take out the V and you substitute 125. And then our formula says that A cubed is equal to 125. If you want to know the measure of A, or just one, we would have to eliminate that cube by taking the cube root of both sides. At the top of the next page is where they're showing you how to do that. Number 2 says complete the prime factorization of 125. We did this in the video. They filled part of it in. What number times 25 makes 125? Well, that number is 5. Remember that once you factor it, it is no longer a part of the factors. Now, 5 is a prime number, 25 is not. We need its factors, and they are 5 times 5, which gets rid of the 25. Number 3 says to write 125 as the product of 3 factors and as a power of base 5. Now, product of three factors would be 5 times 5 times 5. And then as a power of base 5, the base is 5, and we used that 1, 2, 3 times. So what does 125 have in common with a cubed when 125 is written as a power? They want to know, what does a cubed and 5 to the third have in common? Yes?
They both have the same exponent.
Very good. They have the same exponent. They have the same exponent. Which should tell you if the exponents are the same, then the bases have to be the same, so a would equal 5. The product of an integer used as a factor 3 times is a perfect cube. Finding the cube root is the inverse of cubing a number. There's you some more notes. The cube root of a number is the number that is used as a factor 3 times to produce its original number. The symbol, which is given here, notice the index of 3, means find the cube root. Number 5 says, look at the example on the previous page. The equation shows a cubed, or a to the third, equals 125. Use the cube root to complete the solution. Now, we're going to take the cube root of a to the third. If we take the cube root on the left, we have to take the cube root on the right. Now, the first one would be that first factorization, 5 times 25. And then they go one step farther to get 5 times 5 times 5. They've used that factor tree. I do not expect you to do this intermediate step. Go straight to the factors. Now, when I take the cube root of a cubed, the cube and the cube root cancel out, and I'm left with a. Now, to take the cube root of 5 times 5 times 5, I can factor out any groups of 3 factors. Since there are 3 5s, my answer is 5. Each edge of the cube is 5 feet long. Use what you just learned to solve these problems and show your work on a separate sheet of paper. On number 6, we've got y cubed is equal to 8. We want to know how much is y. Right now, we know how much 3 y's are, but we want to know how much 1 would be. The opposite of a cube is a cube root. So if we take the cube root of the left, we also take the cube root of the right, and that's going to tell us our answer. Now, I want to show you this as a factor tree on both sides so you can see why the cube and the cube root cancels. If we factored out y to the third, we would have y times y times y. It takes 3 factors to factor out. There are exactly 3 y's. So the cube root of y to the third becomes y. The cube root of 8, we're going to factor tree there. I've got 2 times 4 makes 8, and 2 times 2 makes 4. It takes 3 identical factors to factor out of the radical. I have 3 2's, so my answer is y equals 2. On number 7, y equals 2. On number 7, I've got the cube root of 20, I'm sorry, not the cube root, the cube, x cubed equals 27. I want to know how much 1x is. Right now, it's 3x's, x times x times x. If I want to cancel the cube, I use a cube root. Anything I do to one side of the equation, I have to do to both sides. The cube and the cube root, said that backwards, cancels out and leaves me with x. I'm going to have to factor 27. 3 times 9 makes 27, and 3 times 3 makes